Hi everybody, this is the second of two videos that will address augmented matrices and linear equations. So we left our first video at this particular point where we showed how we can actually take a linear system and write it as an augmented matrix, where the first column or the first equation is in the first row, the second equation is in the second row, and notice that the matrix only contains the coefficients and the constants, because when we're solving an equation, what are we manipulating? We're not manipulating the x's, we're manipulating the coefficients and the constants. And our goal is to get it into this particular form, which is called a reduced row echelon form, because once we have it here, the solution is obvious. If I took this augmented matrix and wrote the associated equation, which you need to be comfortable in doing to be successful in this part of the course, we would have this. We would have 1 times x1 plus 0 times x2 is equal to 3. And here I would have 0 times x1 plus x2 is equal to negative 2. And you can look at this and immediately deduce that, well, yeah, x1 is equal to 3. And x2 is equal to negative 2. And that would be the solution. Okay, the trick or the task is to get from this form to this particular form, and we need to use our row operations. And do you remember what those are? Well, the first one is you can switch around row 1 and row 2. Well, since we just have 2 rows, you can take, let's say, row 1, add 5 times some number times row 2 to it, and replace it by row 1. Or you can actually take a particular row, say row 2, and multiply it by, say, negative 1/2. I'm sorry, I did that wrong. You could take row 2, multiply it by, say, negative 1/2, and replace that with row 2. Those are the 3 operations. Those are the 3 row operations that we can do. Okay, well, the approach that we use to get our equation from here, or our matrix from here to here, is called the Gauss-Jordan method. And how does this Gauss-Jordan method work? Well, I'm glad you asked, because I'm going to show you how to do it. But before we do that, we need to change our screen setup just a bit. Okay, and here we are. Now, once again, we want to use the Gauss-Jordan elimination method to transform this augmented matrix into this equivalent augmented matrix, and this is called the reduced row echelon form. And the approach that we're going to use is, once again, the Gauss-Jordan method. So let me go ahead and rewrite this over here. We have 3, 4, 1, 1, negative 2, 7. Okay, now remember, and notice that we want this coefficient, or this element, to be equal to 1. So the very first row operation we're going to do is we're going to divide row 1 by whatever we need to, or multiply row 1 by whatever we need to make this element equal to 1, and replace that in row 1. So our first step is to make A11 equal to 1. And we'll do that by taking row 1, multiplying it by 1/3, and replacing that into row 1. Okay? So let's go ahead and do that. And that will give us a new matrix, which is 1, 4/3, 1/3. And of course, what happens to row 2? Absolutely nothing. That is going to be 1, negative 2, 7. So this is our new matrix. Now, in the Gauss-Jordan method, we work column by column on the coefficients. So now that we want to have this equal to 1, we want this to be equal to 0. So we want A2 1 to be equal to 0. If we can do that by taking row 2, subtracting from it row 1, and replacing that back into row 2. And that is exactly what we're going to do here. Row 2, subtract row 1 from it, and put that back into row 2. And what happens to row 1? Absolutely nothing. That will stay 1 4/3, 1/3. Now for row 2, we're going to take row 2, subtract row 1 from it, and put that back into row 2. Well, here we have 1 minus 1, that's equal to 0. For the second part, we're going to take negative 2, subtract from it 4/3, and place that into row 2. And place that into the second one. But let's actually do a little math and see what that is. Well, we can write negative 2 as negative 6/3. You need to have a common denominator. Minus 4/3 is going to be equal to negative 10/3. So we're going to have negative 10/3 here. Yes, we are going to be dealing with fractions. And then finally, we are going to take row 2, which is 7, subtract row 1 from it, and place it here. Well, 7 we can write as 21/3 minus 1/3. That will give us 20/3. And you're probably looking at the fractions and saying, this might be getting a little out of hand. And it does get a little involved in the beginning, but in most of the problems, as you see, it should clean right up. Okay, so we've taken care of the first column. We have a 1 here, which is what we want. We have a 0 here, which is also what we want. Now we're going to look on the second column, and we need to have a 1 here. Okay, so we want A2, 2 to be equal to 1, and that will happen if I take row 2, multiply it by 3/10, negative 3/10, and replace that back into row 2. It should be, no, that's fine. Okay, so let's go ahead and do that. We're going to take row 2, going to multiply it by negative 3/10, and put that back into row 2. What happens to row 1? Absolutely nothing. That will be 1 4/3, 1/3. And then row 2, well, for row 2, well, first element is 0. 0 times negative 3/10 is, well, you guessed it, 0. Now, the next one, we're going to have negative 3/10. Let me do this over here. Negative 3/10 times row 2, which is negative 10/3, and that will be equal to 1. Okay, that's what we want. And then finally, we are going to have negative 3/10 times 20/3. That will give us negative 20/10, or negative 2. So we have a negative 2 here, which is kind of like what we're hoping for, because we know that x2 should be equal to negative 2. And that's actually what this is saying right here. And then finally, we want A12, working on this column, to be equal to 0. And that will happen, I'm kind of skipping all the way down to here, that's 4. And that will happen if I take row 1 and subtract from it 4/3 row 2. And replace that back into row 1. So let's go ahead and do that and see what happens. Okay, so what's going to happen with row 2? Absolutely nothing. That is going to be 0, 1, negative 2. Okay, what about row 1? What about row 1? Well, the first element, we're going to take row 1. We're going to subtract from it 4/3 times 0, which will be, 0. No, which will be 1. All right, 1 minus 4/3 times 0, 1 minus 0, 1. Okay, now for the next one, we're going to take 4/3, subtract from it 4/3 times 1, which is 4/3. That will give us the 0 that we want. And then finally here, we will have 1/3 minus 4/3 times negative 2, that is going to be equal to 1/3 plus 8/3. 4 times 2 is 8. The negatives cancel, makes it positive, which will be 9/3, which will be equal to 3. And this here is our reduced row echelon form. Okay, and we can put this back in equation form, and what does that tell you? That tells you that x1 is equal to 3 and x2 is equal to -2. And that is how you solve this particular problem using the Gauss-Jordan method. Now the question is, will you have to use this in your homework? And the answer is, if you have a TI-84 series calculator, no, you will not have to. The calculator will do it for you. And this brings us to example 8. And this is actually kind of like your first homework problem in part B. And here we want to solve the following system of linear equations using augmented matrix methods. Okay, and then we're going to graph the solution set and talk about the difference between the solution set and the graph of one of the equations. Okay, so before we can use augmented matrix methods, we have to actually write this as an augmented matrix. So for the first row, which is the first equation, we are going to have 2, -1, -7. For the second equation, we are going to have 1, 2, 4. And now we need to find the reduced row echelon form. Now we can use Gauss-Jordan elimination, or we can use our calculator. I'm going to show you how to do this using our calculator. To do this using our calculator, notice that we have this little entry here called matrix, and that's basically what we're going to be working in to actually make this happen. So I'm going to click second, matrix. And the first thing that we need to do is edit a matrix. So let me come over here to edit, okay? And I'm going to edit matrix A. There is matrix A. Now matrix A is going to be a 2x3 matrix. See, there is our reduced echelon matrix. Let me see if I can get the matrix and the equation up. There we go, yeah. It is a 2x3 matrix. Good, we have the correct dimensions. So now we can just go ahead and go down to the first element. Now the first element needs to be a 2. So I'm going to put in 2 and hit enter. And we're going to do this row by row. Next element's going to be a -1. Make sure you use this number here, or this negative here. -1, enter, -7, enter. The first equation is done. Now for the second one, we want to do 1, enter, 2, enter, 4, enter. And our matrix is defined. We now need to quit. Second, quit. We now need to go back into matrix. Second, matrix. And we are going to do some math. So go to math. And if you can click your down arrow to go through all this, or if you click your up arrow, we'll start at the back end. And we want to go to RREF. That stands for Reduced Row Echelon Form. So let's go on up there. Okay, hit enter. Now we need to name the matrix. To do that, yes, you have to go back into matrix again. We put all of, and remember we did all this in matrix A, so here we are selecting matrix A. If we actually move to edit, we'd be editing matrix A, but here we are selecting it. And there it is. Close the parenthesis, hit enter. There is your matrix in reduced row echelon form. And that is, I'm going to write it over here. That is going to be, that is 1, 1, 0, -2, 0, 1, 3. And that right there tells you that x1 is equal to -2, and that x2 is equal to 3. All right. Let me make this a little smaller, and let me make this a little larger. So the solution set is going to be the point negative 2, comma 3. I'm going to call this x1 and this x2. The second part of this problem is to graph the solution set. Okay, let's go ahead and do that. Well, the solution set is one point. It is the point negative 2, 3. So let's go over so what you're going to do is just find that point 1, 2, the negative 2, 1, 2, 3, that right there. This is the graph of the solution set. Okay, so that's part B. Now part C is asks the question, what is the difference between the graph of an equation in the system and the graph of a solution set? Well, remember, these are linear equations. The graph of any one of these equations is going to be a line. The line's actually going to go through that point. Okay, so an equation is a line. The solution set is one point. For the rest of this video, I am probably going to use this format because once again, we're going to be using our calculator to solve most of our problems. So here in this example, it's example 10. I skipped example 9 because it actually was just example 8 all over again. We want to solve this system of linear equations using our calculator. Now, before we can do that, we need to write out our augmented matrix, and that would be negative 2, 6, 6 for the first equation, and then 3, negative 9, negative 9 for the second equation, which of course relates to the second row. And this is what we want to put into our calculator. So let's come over here, second matrix, we want to edit, and let's go ahead and just do A again. Okay, this is once again it's a 2 by 3 matrix. The first element is a negative 2, 6, 6. And then over here we're going to have 3, negative 9, negative 9. Okay, so that looks correct. Now we can quit. You can go back in. We want to do reduced row. Oh, we want to go to math, and we want to go to reduced row echelon form. Enter. Go back in again. Second matrix. Highlight A. Close parenthesis. And that is our reduced row echelon form. We have 1, negative 3, negative 3. And here we have 0, 0, 0. Now, this is a little different than what we've seen before because we're used to seeing 1, 0, 0, 1, and then a number here say 5, and a number here saying 10. Here we have all zeros. As a matter of fact, if you actually wrote down the equivalent equations, you would have that x1 minus 3x2 is equal to minus 3. And the second one is that 0 equals to 0. This tells you, if you ever have something that looks like this, that tells you that you have an infinite number of solutions. Infinite number of solutions. Or that the solution is the solution set are all points that are defined by this particular line. Now, when you see this in your homework, this is what they're going to do. They're going to say, well, then they're going to say, okay, let x2 be equal to t, and then write your solution set for x1 in terms of t. Okay, so we're going to let x2 be equal to t. And then if we do, we are going to have that x1 minus 3 times t is equal to negative 3. And then x1 is going to be equal to 3 times t minus 3, solving for x1. Then your solution set is going to be all the points 3t minus 3, that's x1, comma, t. That's what you're going to be looking at. And actually, I will show that to you in an MML example later in this particular video. So that is example 10. Let's take a look at example 11. Okay, the first thing we need to do is write this as an augmented matrix. Or you might be comfortable enough, or after you've done this a few times, you might be comfortable enough to look at this equation and write the augmented matrix directly onto your TI calculator. So let's go ahead and do that. Second matrix, we're going to, that's not matrix, that's math. I always do that. Let's get out of that. Second matrix, there we go. You want to edit. Matrix A. Once again, it's a 2 by 3 matrix. Now remember, the first row is the coefficients of the first equation. So over here we're going to have 2, -1, 3. 2, -1, 3. And then the second row are the coefficients of the second matrix. 4, -2, -1. Okay? Once we've done that, we can exit, or we can quit. Now, you could go back into matrix into matrix and do second matrix, math, reduce row echelon, go back into second matrix, select A, and have at it. But also you can notice, well, basically what you're doing is you're rewriting this. That's in your history. You can go to that command, hit that command again, hit enter, and it will do that command. And that would be your answer. Now take a look at what we have here. Our augmented matrix is going to be 1, -0.50, 0, 0, 1. Okay? Now, first row says that x1 minus 0.5 x2 is equal to 0. That's what the first one says. The second one says that 0 times x1 plus 0 times x2 is equal to 1. Now 0 times x1 is 0, 0 times x2 is 0, so this says that 0 is equal to 1, which is a false statement. Since this is a false statement, this system has no solution. This statement is inconsistent, or this system is inconsistent, and you would want to mark that accordingly. One more thing. Now look at this augmented matrix. Right here we have a fraction which is -1, which is -0.5, or a decimal which is -0.5. Sometimes it might be better to look at this as a fraction. Now how can you do that? Well, what you can do is in your calculator, go to math. Notice the first element there is fraction. So just go ahead and click on that. Okay? And then I think all you need to do is hit enter. And then it will give you the fractional form. And the last 3 examples were examples of the 3 possible solutions for a system of equations. The first one is that you have exactly one solution. And in that particular case, we have essentially ones on the main diagonal for the coefficient part, and we can quickly deduce that x1 is equal to m and x2 is equal to n. The second one is for the case where we have all zeros in the second row, which basically implies that 0 is equal to 0. And when you see something like that, that tells you that you have infinite many solutions, and that solution will draw a line for you, or all those solutions will draw a line for you. And when you see that, what you want to do is you want to let x2 be equal to the dummy variable t, and then it will walk you through it, and then x1, and then once you have that, we are going to use the first row to solve for x1. And then finally, if you have something like this, where the second row implies that 0 is equal to p, where p is not 0, well, then you have no solution and you have an inconsistent system. Now, before I conclude this video, I'm going to walk through 2 problems which I believe will help you as you do your homework. And I'm going to walk through those 2 problems in MML. Okay, this is the first problem that I wanted to do, and the main reason why I wanted to do this one is because it requires a little graphing. I want to make sure we're comfortable with that. So here we have 4x1 minus 2x2 is equal to 16, and 6x1 minus 5x2 is equal to 8. So let's go ahead and write the augmented matrix. That would be, for the first equation, 4, negative 2, 16, and then 6, negative 5, 8. This is what we want to put into our calculator. So let's go to second matrix. Edit. It's a 2 by 3. Cool. 2 by 3. And then we were going to have 4, negative 2, 16, 6, negative 5, 8. Okay. We want to quit. We're going to go back into matrix. We're going to go to math, reduce row echelon form. And then we want to select A, second matrix A, close the parenthesis. And that would be our solution. And that should tell you right now that x1 should be equal to 8. And x2 is also equal to 8. If it's not clear and at the risk of being redundant again, the equation associated with the first row is x1 plus 0 x2 is equal to 8. And the equation associated with the second row is 0 times x1 plus x2 is also equal to 8. And of course, we can deduce that from there. So we have a unique solution, and that is that x1 is equal to 8 and x2 is equal to 8. Now for the next part, we need to plot the solution. And the question here is, which graph represents the solution set for our given system? Now remember, the solution set is a point, and it is the point 8, 8. It is not a line. So it can't be C or D because those are lines. Well, let's take a look at B. I'm going to look at B first because I already know that the answer is A. Well, there's nothing plotted, so it certainly can't be B. The answer here is A because the solution set is the point 8, 8. So all you need to do is recognize that, click A, and you're good to go. And then the final question is, what's the difference between a graph of an equation in the system and the graph of its solution set? Well, remember, these are linear equations. This graph is going to be a line. The solution set is exactly 1 point for this particular problem. So the graph of an equation is a line, whereas the graph of a system solution is a point. That would be A. And that's all there is to the first problem. Okay, here is question 2. And once again, here all we need to do, actually there are 3 parts. I didn't realize that. Here we want to solve the system below using the augmented matrix methods and then graph the solution set. Okay, so let's go ahead and do that. Once again, our augmented matrix is going to be 2, negative 5, negative 7 for the first equation, 6, negative 15, negative 21 for the second equation. Let's go ahead and put that into our calculator. Second matrix, not second math. I've made that mistake once already. Edit. And we're doing matrix A. It's still a 2 by 3. And just put the data in. Here we're going to have 2. Enter. Negative 5. Enter. Negative 7. Enter. 6. Enter. Negative 15. Enter. Negative 21. Enter. Okay, go ahead and quit. Now we could go back and do the matrix stuff, but all we're going to do is basically repeat this command for the exact same matrix. So I'm just going to highlight that in my history, hit enter. That is my answer. Now notice that my reduced matrix is 1, negative 2.5, negative 3.5, 0, 0, 0. That row 0 tells you that we have infinite many solutions, so our answer is going to be B, where x1 is equal to something and x2 is equal to t. We need to use the first row to figure that out. And once again, we want to type the expression for x1 using t as a variable. So the first row tells us that x1 minus 2.5 x2 is equal to negative 3.5. All right. Remember, we want x2 to be equal to t. So we have x1 minus 2.5 times t is equal to negative 3.5. Adding 2.5t to both sides, we will have that x1 is equal to 2.5t minus 3.5. That is the answer, what we want to put in here. And you could put it in as a decimal, or you could put it in as a fraction. I'm going to try to put it in as a decimal. That would be 2.5 times t minus 3.5. And there you go. Now, if you wanted to express this as a decimal, once again, you just hit math, fraction, and that's what it would look like in terms of a decimal. Okay, so that's the first part. What's the second part? The second part is which graph represents the solution set for the given system of equations. Well, notice here now, x1 is expressed in terms of x2. This is a line. It is exactly one line because actually both equations are the exact same line. So it's not a point, cannot be A. It's not two lines because each of these equations plot the exact same line, can't be B. If you take a look at C, it's nothing. There's nothing. There's nothing graphed there. So it has to be D. D shows exactly one line. You can give yourself more confidence that it's D because when x2 is equal to 0, x1 is equal to negative 3.5, which is exactly what we would expect. So it is indeed D. You don't need to go that far. Just the fact that it shows one line is sufficient. We can check our answer, and yes, we are correct. Now notice, and that brings us to part C. In this particular case, what's the difference between the graph of the equation in the system and the graph of the system solution set? In this particular case, they are all the exact same line. So there is no difference. So it's D. For my last problem, let's take a look at this example right here. Here we have 5x1 minus 3x2 is equal to negative 4, and negative 5x1 plus 3x2 is equal to 3. And once again, we're going to solve this using our calculator. Now, instead of writing out the matrix, I'm going to write the matrix on our calculator strictly from the system equations that we have here. So to do that, I'm going to go second, matrix. Almost made that mistake again. Go over to edit. We are going to do A again. It's already a 2 by 3 matrix, so I can go through there. Now remember, the first row corresponds to the first equation. So we're going to have 5, negative 3, negative 4. 5, negative 3, negative 4. For the second row, we're going to have negative 5, 3, and 3. So negative 5, making sure you use this negative, 3, and 3. Okay, we can quit. Go back, and no, we don't need to go back in the matrix. I'm going to come up here and reuse this command. And here is my solution. Now, if I want to put this in terms of a fraction, I can go to math. It's already highlighting fraction. Just hit enter again, and there it is as a fraction. And my reduced matrix is going to be 1, negative 3 halves, 0. And here we're going to have 0, 0, 1. And recall that the second row implies that 0 is equal to 1, which is a false statement, which means there is no solution. So when you have something like this, you know there's no solution, just click there and you are correct. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.